Good day, everyone. Today I just want to carry you along with my live troubleshooting in the fiber optic world. We have a network issue affected by our fiber route, and then I decided to troubleshoot it. We go with some of my equipment, splicing machine, OTDR. So the splicing machine will be used to splice the pigtail to the live fiber. Then we will use different options in the OTDR to locate the fault. So some pre-tests were carried out. The distance was already determined. You can see our closure has fallen, so the problems affected that. So we have determined the point of cut, but we don't know the exact cable that belongs to us. So that's where the OTDR will play its role. We can use the VFL to send a light signal to determine where the light come out from. That will help us to determine our cable, or we can also test the fiber that are carrying power to find out which of the fiber is our own as well. But the light one is the easiest one. It's used to help us to determine whether the cable is truly ours. So we send the light source from our closure to find out. So I'm checking out this cable, look like our own, but I'm not 100% sure because there are so many other vendors' cable that has been affected. So in this case, we use first of all check the power on the cable if the power is on it, because I know the cord that is carrying power. So I'm preparing the cable now to run a test on it. I know that cord 3 and 4, one is transmitting, the other is receiving. So one of them should be carrying power. So if I carried out that test and I can't get the power from it, then I will proceed with the option of VFL, which is to send light. Then when the light appear, I will know that this is my cable. So at this point I'm preparing the cable. So this is the buffer I'll be using. So that is the live buffer. We use it. The other buffers are not in use, so not all the cores in the buffer 1 are in use. So we use core 1 to 4, so 3 and 4 are transmitting and receiving. Anyway, so you expose the fiber by cutting off the buffer, pull it out, then you clean it with tissue and expose the fiber fully. That's what I'm doing now. So we are just preparing the fiber at the moment. Yeah. So bring out your machine, that is the splicing machine. So pick the battery. So insert the battery into it. Bring out the OTDR. You need both to carry out these tests. This is a pigtail that will be spliced to the live fiber. So you need a pigtail. So now the next thing is to strip off the fiber, removing the cladding to expose the ray glass. So that's what I'm going to do now using stripper. So I'm trying to select the right core because there are multiple cores. There are about 12 cores in one buffer, and not all the cores are in use. So I'm trying to select the right cores, which is core 3 and 4, which I was aware is carrying power. So stripping right now. Careful not to damage or cut the fiber. So you may be wondering which one is core 3 and 4. There's an assignment for you. There is a color code for them that number them. So the next thing is to use a cleaver to cut it properly, to cleave it up. So you clean with alcohol first before you cleave. So it's very sensitive to dirt, so we always wipe it with alcohol. That's methylated spirit anyway. Alright, so place the fiber across this cleaver. So the strip edge should cross the cleaver. So maybe another day I will dedicate a video that will show it properly in maybe in an office, because this is a field. We are not concentrating more on the video, so I can zoom. I'm not the one doing the video by myself, so I don't have time for that. So the fiber has been cleaved, meaning it has been cut with a fine edge. The purpose of using the cleaver is to cut it properly with a fine edge so that the splicing machine will not reject it, we accept the smooth edge. So the next thing is to place it inside the splicing machine one from the X-axis. So make sure the fiber don't cross the stainless steel, two stainless steel pointing each other inside the splicing machine. They should be so close to it, but they shouldn't touch it nor cross it. Okay. So the next thing is to strip the pigtail as well, then clean with alcohol and cleave and place it from the Y-axis as well. So that's what I'm trying to do right now. Right, open your cleaver, then place it in across the cleaver. Close the cleaver, close the second edge, press that button to cut. There's a pointing button out there, you press it to cleave it. There's some kind of cleaver that once you just close it, it will automatically cut, but this type is different, so you have to press a button on the side of the cleaver. So properly set the pigtail inside the splicing machine too. Make sure it doesn't cross the stainless pointing element. Should be closed but it shouldn't cross. Then close it. Then this machine is automatic. Once it detects a fiber, it will splice by itself. So I'm sorry, the screen.
Alright, so the display is affected. So anyway, it was not spliced because the cleaving was not properly done. So I'm going to re-cleave and then splice it again. So that's what I'll be doing right now. I've done that and then I've connected back, and you can see it's properly spliced this time around, so it's no longer rejected. Alright, so you bring out your machine to carry out the power test. So open the OTDR, the back cover here, to expose the different ports. Some are written OPM here. This particular one is written OPM, which stand for optical time power meter. Alright, so you shake power there. If you want to shake your power from media converter, place it there on the screen. There's where it's written OPM. So you put it OPM. As you can see, there's no power on it right now. If there's power, it will be reading. The minus 50 will be decreasing. So as there's no power on that cable, it's constant. So a good power will be reading minus 10 below, and it will be green. A poor power will be reading red, and it will be like 25 upward. So as there's no power, I'm going to do a distance test. So to do a distance test, you patch it to that port. So go to either expert OTDR or auto OTDR. Then you click on display button, but this one is also a screen touch version, so you can select test on the screen by tapping it. Alright, so at this time is going out based on the graph. You can check the distance on that graph, or you can go to the list. You see the distance. The arrow pointing out is the distance. There are different losses that you can see there, but at this point I am getting 180 meters, so that's close, but I'm not sure if that cable is truly out, since there's no power on it, and then getting there is no power on it. So I've decided to use the other method of testing. So I want to be sure the cable is truly out. So that was supposed to be the first test I would have done, but I was just confident the cable was out, but unfortunately it seems not to be out. So I'm going to use the VFL method now. So I'm going to send the light signal from the closure to see where the lights come out among the multiple affected cables. So there are other vendors cable there, so I'll splice it from the closure. So you go to VFL, the option is there. At the back also it is written VFL, that's the port that you are going to patch. So when you select the VFL, there is option where you're going to click normal, then it will give out a constant light. I've selected that. You can also select some frequency, it will be blinking. So yeah, I can see this is our cable. So that's where the damage is. So the light, you can see the light here. So it's used to trace a cable among the multiple available cable. So there are other suspended cables up there, but I don't know which one is our own. They are both 96 core, so that was confusing. I need to differentiate our own to identify our own, so that's where you come up with the use of VFL. It's also used for that testing a troubleshooting method where you are in another point and you want to show if the distance is reaching there, then you can also send like that. Alright, so since we have already discovered the point and we have determined our cable, so the next is to mobilize on a rigger that will climb the pole to bring down the cable for us, or maybe if the cable cannot be used again, we will change the cable entirely, then we will lay another cable. Alright, so after some times later, we were able to get a rigger that is going to climb the pole and lay a new cable for us. So that's what he's doing right now. He has pulled out the cable from the other end, so this is the last edge right now. So after I finish that, we are going to do the splicing. So to reduce the time, I'm not going to show you how to do the splicing again. That will be another day's video where I'm going to set up a lab in the office to show you properly, where you'll be seeing how to set your fiber inside the splicing machine, how to cleave, how to strip, and how to clean with alcohol. So what I'm doing in the field right now doesn't focus much on doing the video very well, so I'm sure because of the sunlight and the environment you are not seeing it very well. So I promise I will dedicate a video for that, on how to splice, how to the necessary tools required, and the different feature in OTDR. That will be another video for another day also. Alright, so the cable has been brought down. So at this point, after coiling it, we will set up the cable, then splice it on a permanent base. So I just show you how to make some minor splicing now, where we splice to a peak. Alright, here is a clearer view of the OTDR. At the earlier time, we were in sunny side, so it was not clear when I video. So here is the back view. So if you want to test light, want to send light source to trace a cable, to identify your cable, you use this VFL. If you want to test distance, you use where they write OTDR and LS, and if you want to check power, you use where they write OPM. Alright, so thank you for watching. So don't forget to like and subscribe to my channel. More exciting videos are with you. So thanks for watching once again. Share with friends and anyone that is in the field of telecommunication and technology.